Next, we'll move on to Newton's three laws. Okay, so we need to understand what are the three laws. Okay, so Newton's first law states that an object at rest will continue to be at rest unless a resultant force acts on the object. Okay, long story short, basically Newton's first law is inertia. Yeah, okay, inertia means that if an object is moving, it will find it very difficult to stop moving unless I use a resultant force to oppose the object, or when I'm at rest I will find it very difficult to move. Right? And what affects the magnitude of your inertia basically is the mass. Okay, so if your mass is high, means that you will have a high inertia. Okay, so for let's just say for a double-decker bus, a double-decker bus will find it more difficult to start moving when it's at rest, and after it starts moving, right, when it sees the traffic light, right, it finds it more difficult to stop because of its high inertia. Alright, okay, so that's Newton's first law. Okay, so if you look at this diagram, right, the lorry inside got a huge chunk of stone. Okay, when the lorry suddenly stops or suddenly brake, right, the stone will continue to move forward due to inertia. Okay, so inertia can be quite dangerous. Okay, so let's go to Newton's second law. Newton's second law is the most important law under the chapter of forces. Okay, so Newton's second law states that the rate of change of momentum is directly proportional to the resultant force, and this occurs in the direction of the force. Okay, so sorry about that, because I think I need to this is not the correct definition for O level, right? So I will give the correct definition next time, right? So F is equal to MA, right? So your F is your resultant force. Okay, your M is your mass, and A is your acceleration. Okay, so yeah, so let's take a look at this diagram. So if you look at the first diagram, right, we have two forces acting on this object. So what is the total resultant force? Since they're acting in the same direction, the total force should be 60 plus 30, so it's just 90 Newton. So this is how you calculate your resultant force. The second diagram, you notice that the first force 30 Newton, second force 10 Newton backwards. So the total resultant force should be 20 Newton towards the right hand side. So this is how you calculate resultant force. Okay, so of course, try yourself one. We have the Scooby-Doo van. So this Scooby-Doo van total has a mass of 600 kg. So what is the acceleration for each of the scenario? Okay, so first we have a resultant force. Okay, we have a resultant force towards the right hand side of 700 Newton. Okay, so if you use F equal to MA, right? So your F is 700, your M is 600 kg. So your A is about, let's calculate, it's about 1.17. So this is 1.17 meter per second square. Second will be your, okay, second is 900 Newton towards the left, 400 Newton towards the right hand side. So the resultant force is, okay, so the resultant force is 500 Newton towards the left hand side. Right, so F equal to MA. So F is about 500, your M is about 600, so your acceleration is 500. So it's about 0.833 meter per second square. So the direction of your acceleration must be the same as your direction of your resultant force. Just take note of that. Alright. Okay, last but not least, the 1000 Newton towards the left and 1000 Newton towards the right hand side. So there's no resultant force, right? Since there's no resultant force, there shouldn't be any acceleration at all. So it's either okay, so when I say there's no acceleration, it can mean two things. First, the v is equal to 0, means that it's not moving. Second, it is moving, but the velocity is constant. Okay, so let's just say you are traveling at 20 meters per second. It will always be 20 meters per second. It will not increase or decrease. Right? So just take note of that. Okay, let's go to checkpoint 3. So we have a car and the engine produces a driving force of 5,000 Newton on the car. So the resistive force, this can be friction or air resistance, as shown. The car has a mass of 800 kg. So this one is the mass. And the acceleration of this car is about 1 meter per second square. What is the value of R? Okay, so first of all, we need to determine what is the value of your resultant force. So the value of the resultant force is 800 times your 1. So the value of resultant force is 800 Newton. And of course, the resultant force must be in the forward direction. Cannot be in the backwards direction. Doesn't make any sense. Right? So we have a resultant force of 800 Newton forward. Okay. So what is the meaning of the resultant force? Resultant force basically is this 5,000 Newton minus away R will give me the resultant force of 800 Newton. Alright. So 5,000 minus R equal to 800. So you just manipulate accordingly. You should get R equal to 5,000 minus 800 is about 4,200 Newton. Okay, so answer should be B. Checkpoint 4. So we have the diagram shows 4 identical objects. Each object is acted by only 3 of the forces shown. So what object accelerates towards the right, and what with the smallest acceleration? So I want the object to accelerate towards the right. Since the object accelerates towards the right, means that my resultant force, there must be a resultant force towards the right also. Right? Okay, and with the smallest acceleration means that my resultant force must be low enough, but not 0. Okay, not 0. So let's take a look at our option A. Option A, if you take a look, is 50 Newton towards the left, 10 Newton towards the right. So cannot be right, because there will be a resultant force of about 50 minus 10, 40 Newton towards the left. Okay, option B, if you look, 30 Newton towards the right, 30 Newton towards the left. So the resultant force is 0 Newton. Okay, even worse. Right? C, 40 Newton towards the right, 20 Newton towards the left. So we have a 20 Newton resultant force towards the right. Okay, so last but not least, 10, 20, 30 all acting towards the right. So it's about 60 Newton towards the right. Okay, so our answer should be C. Okay, let's go to checkpoint 5, which is a 2009 O-level question. So a trolley weighing 5 Newton so is put along a level bench by a horizontal force of 10 Newton. So this is 10 Newton, and we have a weight of 5 Newton, right? So the force of friction acting on the wheels is about 2 Newton. So this is 2 Newton right here. Okay, what is the size of the resultant force causing the trolley to accelerate? Okay, so for this is actually a trick question because of this 5 Newton. This 5 Newton actually is irrelevant to the question because I'm moving from left to right. I'm moving in this straight line manner. It's not up to down. If I'm moving up to down, the 5 Newton actually makes some difference. But since I'm moving left to right, The 5 Newton weight is we don't need to care basically. Alright, so 10 minus 2 will be the resultant force of 8 Newton B. Okay, checkpoint 6, also a very interesting question. So, a small submarine of mass 1000 kg sinks in water with a uniform speed of 2 meters per second. So, what do I mean by uniform speed? Uniform speed means that acceleration is equal to 0. What is the resultant force exerted on the submarine as it sinks? So, resultant force is your F, right? Since your F is equal to ma, your A is 0 already. Do you have any resultant force? Definitely no. So answer is A. Okay, so just something to take note of is that when, although you do not have any so-called, let me just draw a submarine. You do not have any resultant force. Doesn't mean you do not have any forces acting on it. Okay, just that the so-called the forces cancel out each other. So your submarine has a mass or weight of 10,000 Newton. So this is your weight, and there's a so-called upward force. This is what we call the upthrust lah. So your upthrust should also be 10,000 Newton. Okay, so these two forces are cancel out. That's why your resultant force is equal to 0. Right. Okay, checkpoint number 7. So it's a 2015 question. A car of mass 800 kg so has a forward acceleration of 2.5 meter per second square. A frictional force of about 1200 Newton oppose the motion of the car. So what is the driving force due to the engine of the car? Okay, so whenever we have such a scenario, let me just draw the route. So this route is a horizontal level route. Okay, so I have a forward driving force. I do not know what is this, so I just put maybe D D for driving force. I know the frictional force. The frictional force is about 1200 Newton. Okay, so they say, hey, what is the driving force of due to the engine of the car? Okay, but one thing that I know is that I have my mass and I have my acceleration. Since I have M and A, right, I can calculate what is the resultant force. Yeah. Okay, so you just calculate F is equal to MA, where M is 800, your A is 2.5. Okay, so you just calculate accordingly. You should get about 2000 Newton. This 2000 Newton is your resultant force, not your driving force or not your frictional force. Okay, so 2000 Newton is right here. So we have a 2000 Newton. Okay, so whenever I represent my resultant force, I always put double arrow to help you see better. Okay, so I know that resultant force is D minus away my 1200 Newton must give me 2000 Newton. Alright. Okay, so you just do accordingly. So D minus away 1200 equal to 2000. So definitely your driving force must be equal to 3200 Newton. Alright, so D answer is 3200 Newton. Okay, checkpoint number 8. In which situation is no resultant force needed? So in order for your F to be 0, you must not be accelerating, or you must not be decelerating, because decelerating is just another form of acceleration. Just that maybe you're moving here, right? So let's just say this is a car. You're moving in this direction. Because in front there's a so-called traffic light. This traffic light turn red, right? Okay, so you need to slow down, decelerate to a stop. So you must decelerate. So acceleration is just opposite to your motion. This is called deceleration. If you are getting faster and faster, means that your acceleration must be in the same direction as your velocity or your speed. Okay, so so this is your assumption 0. A car changing direction at a steady speed. So this one we will see later. B, a car moving in a straight line at a steady speed. C, a car slowing down. D, a car speeding up. So definitely it's not C, definitely it's not D, because both are the speed is changing. So left A and B. Which one should we choose? The similarity between your so-called A and B is for A, the car is moving in so-called a circle, right? So you are going around a circle. For B, your car is moving in a straight line at a steady speed. So let's just say this is 50. You are moving at 50 meters per second towards forward. Okay, so here is also 50 meters per second. So which one should we choose? We should choose B, because for B there is really no resultant force. But what about A? A, you are changing direction. Okay, if you remember, when a car changes direction, although the speed is the same, but the velocity is not the same, because velocity, let me just erase this, because remember, velocity is a vector. Velocity is a vector. So what is a vector? Vector basically means I have both magnitude and I have the second is the direction. So what is magnitude? Magnitude is like, okay, so you are traveling at 50 meters per second, right? The magnitude is 50. It's the number, the size of your speed. Okay, so your magnitude is 50. And if you're moving at a steady speed in a circular motion, the 50 will remain the same. Okay, so that's okay. So your magnitude is the same, but your direction keeps on changing. Because you're moving in a circular motion, right? So at one point you are facing towards the north. The other point, after some time, right, you are facing north, south, east. Okay. The third point, you are facing towards the south. Last but not least, you are facing towards the west. So you can see that your direction keeps on changing. So in this case, although your speed is 50 meters per second, but I must conclude that my velocity is not constant. Okay, since your velocity is not constant, means that there is acceleration, because acceleration is the rate of change of velocity. So there must be a change in velocity in order to have a acceleration. Okay, so answer should be B. Right. So just another point is that if you say that option A has a resultant force, right? What is the direction of the resultant force? Okay, so whenever you're undergoing circular motion, the resultant force always acts towards the center of the circle. This is what we call the centripetal force that you will learn if you take physics at a higher level. Alright, so this is for checkpoint 8. Okay, the last law of Newton will be the third law. Okay, so third law may seem trivial, but actually there's actually a lot of underlying concept behind it. Okay, so Newton's third law states that every action has an equal and opposite reaction force. So example is that a rocket, right? How does a rocket fly, or how does a rocket go forward? Is by Newton's third law. Okay, so Newton's third law, the rocket will push the gas. In turn, the gas will push against the rocket. That's why your rocket will move forward. Okay, so likewise, if you have a gun or a machine gun, you shoot the machine gun, okay, or the gun, you notice that there will always be a recoil. Why is there a recoil? It's because the gun exerts a force on the bullet. In turn, the bullet will exert a force on the gun. So that's why you will have a recoil. Okay, so this is due to Newton's third law. Right. Okay, so so for C, tire pushes on the road and road pushes on the tire. Okay, so that's why for road and walking, your frictional force is always in the same direction as your motion. So this is your motion. Okay, and for for D is the action. The earth pulls on the ball, and actually the ball also pulls on the earth. So imagine I have the earth right here. Okay, I'm free falling towards the earth. Okay, so the earth will exert a force on me. This is what we call weight. But I am actually also exerting a force on the earth. Okay, it's equal magnitude, just opposite direction. But how come the earth is not moving towards me? It's because the earth is so much massive than me. Right? Okay, so action and reaction forces. In order to fulfill the action and reaction forces, we know the first half of the story. Equal magnitude, opposite direction. This one is easy. The third they must be the same type of forces. Okay, so what do I mean by that? Okay, imagine for number 3, imagine I have a wall. Okay, so this is the wall. Okay, and I use my finger to push on the wall. Okay, so this is my finger. So this finger will exert a force on the wall in this particular direction. In turn, the wall will exert a force on my finger. Okay, so this will be the direction. They are the same magnitude and opposite direction. Okay, so same type of forces means that this purple force and the red force, they must both be contact force. Okay, the nature of the force must be the same. Right, so this must be contact force, this must also be contact force. Okay, if the purple force is contact force, but the red color force maybe is what we call weight. This will not be the same type of force, because weight and contact force, weight is gravitational force, contact force is just contact force. So they shouldn't be the same type of force. Okay, and last but not least, let me just erase it. Okay, last but not least is they must act on different body. Okay, so act on different body, what do I mean by that? So my finger, same scenario, my finger push on the wall. So this force is acting on the wall. Okay, then in turn my wall pushes my finger, right? This force, red color force, is acting on my finger. Okay, so you'll notice that the two forces are actually they are acting on different substance or different object. But in physics we call it different body lah. Right? So wall here, finger here. They must be acting on two different body. So that's why the force cannot be cancelled out. Right? Unlike your Newton's second law, if we go back to Newton's second law, right? Newton's second law we cancel like nobody business, right? So let's just say for this diagram A, 10 Newton here, 20, 30 Newton leftwards. So 50 minus 10, 40 Newton leftwards. Why can I do that? Is because all these three forces they are acting on the same body, same box, right? That's why I can cancel. But if the three forces are acting on different body, I can't do that already. Alright? Okay. So yeah, so that's the difference between your third law and second law. Okay, so if you look at try yourself too, I have a box on the table, and this box has a weight, and of course the table will exert a normal contact force on the box. So do they form an action and reaction pair? Why? Okay, so of course if you look at the direction, they are opposite in direction, so this fulfill the second criteria. What about the first criteria? Equal in magnitude, definitely yes. Okay, so let's just say this is 200 Newton. The normal contact force must also be 200 Newton. Yeah, so this is fulfilled. Okay, what about number 3? Same type of forces. The weight itself is actually a gravitational force, G force. But for the normal contact force, it's just a contact force. or what we call the mechanical force, whatever they like to call it. So the nature of the forces is not the same. Okay, so same type of force didn't fulfill. What about the fourth criteria? The fourth criteria also didn't fulfill because the both forces are actually acting on the same body. The weight is acting on the box. Okay, the normal contact force is also acting on the box. Okay, so you notice that the two forces are acting on the same body. So we can conclude that W and normal contact force are not action and reaction. Okay, in order to be action and reaction, you need to fulfill all four criteria. You fulfill three criteria but didn't fulfill the fourth, the one criteria. That one also won't fulfill the action and reaction pair forces. Okay, let's move on to try yourself 3. Okay, try yourself 3, we have a moon and the earth. So are the forces action and reaction force? So of course we know that the moon revolves around the earth, right? So there must be a gravitational force right here, and the earth also experience a gravitational force by the moon. That's why you have high tide during the night, because the moon gravitational force will pull the sea. That's why the level will rise during the night or during the evening. Okay, so let's see. Okay, are they equal in magnitude? Yes, definitely. Second, opposite direction? Definitely, yes. Third, same type of forces. So this is G force, gravitational force. The blue color is also gravitational force. So they are same type. Okay, last but not least, both forces are acting on different body. Yes, because this red color is acting on the moon, but the blue color force is acting on the earth. Okay, so yes, they are acting on different body. So they are action and reaction force. Okay, let's move on to checkpoint 9. So checkpoint 9, we have a skydiver jumping from an aircraft. The earth exerts, of course, downward force on the skydiver, who also exerts the upward force on the earth. So which statement is correct? Alright, so you notice that this is actually an A-level question. This is actually action and reaction forces. The two forces will not cancel out. And the two forces must have equal magnitude. So answer should be D. Right. Okay, checkpoint 10 is also a bit of trick question. If you are not careful, you might treat it as a Newton's second law. So the propeller on a boat pushes water backwards with a force of 2000 Newton. So the boat, of course, moves through the water against a total resistive force of 1800 Newton. What is the forward force on the propeller due to the water? Another way of saying is that what is the force that the water exert on the propeller? Okay, since my propeller exert 2000 Newton on the water, so according to Newton's third law, right, the water must exert back 2000 Newton on the propeller. Alright, so answer should be C. Okay.